Okay, so next week you will be performing a pH titration. These are very big in AP Chem. We are going to do 2 trials only. First one will probably be more practice for you. The second one will be one where we're going to take our data. If your first one's good trials, then we can keep that data too. But first, before we get in there, you need to understand what is going on. Okay. So the purpose of this first titration is to find the unknown concentration of a strong acid using the base of an unknown concentration. So your strong acid is going to be an H2SO4, and we don't know the molarity of that. But we are going to be using a base, which is NaOH, sodium hydroxide, and we're actually know the molarity of this base. So the equation is going to be H2SO4 plus sodium hydroxide, and we're going to get water, HOH, plus a salt, which is Na2SO4. We balance this, we get 2 there, and we get a 2 there. We are going to use 0.25 molar sodium hydroxide. We do not know the molarity of our H2SO4. So if you go back to our discussion yesterday, I said the first thing you need to do is you need to find the moles of your known. Once you find the moles of your known, then you're going to find the moles of your unknown. After you've found your moles of your unknown, then lastly, you can find the molarity of your unknown. Okay, because we are going to find the moles, and we know how much of that we have, and that is going to be 0.01 liters. So what you're going to do is you are going to have 10 mils of your sulfuric acid. And we are going to titrate that with sodium hydroxide, 0.25, and we're going to figure out how much of that sodium hydroxide does it take to get to equivalence point to neutralize that H2SO4. So this is going to be the required amount to reach equivalence point. And we're going to use stoichiometry to figure this out. And remember, equivalence point is what? Equivalence point is when my moles of my H plus is equal to my moles of my OH minus. So before we start this, what equipment is going to be needed? Some of this equipment you've seen before, some of it you haven't. So what we're going to have is you're going to have a ring stand, which is this thing right here. And attached to this ring stand is a burette clamp, which is a clamp that has 2 sides which can hold a burette. And so this is the burette. You should remember that from back in pre-AP. And the burette is going to be in this clamp, and we are going to, that's what we're going to have our sodium hydroxide in. This whole setup is going to be, underneath here, is going to be a magnetic stir. Okay, so we're going to turn this on, and what happens is we're going to put a magnetic stir bar, which is this thing here, this little pill looking thing. We're going to put this in here, and we're going to turn on the machine, and it's going to start going in a circle, and it's going to start mixing up our solution that is in there. And this will give us a constant mix of our solution. Okay, so then once this is all set up, you are going to need, during the titration, a pH probe, and it will be in this little bottle, which is a case. You'll just unscrew the lid, and you're going to keep the lid onto the probe, leave the lid on the probe, and you'll just put the probe, we're going to set it up in a clamp that is on the ring stand, and we're going to place that into your beaker filled with your solution. The probe has a glass tip. Ions are able to flow in and out of this tip, so please be very careful. And what you need to do is you need to make sure that you're rinsing this off prior to putting it in your solution. Rinse it off with distilled water to get any of the salts on it off. This sensor will be hooked up to the LabQuest. This isn't exactly the LabQuest we're using, but we did use that last week in our Beers Law lab. And then you'll have the funnel, which will help you fill your burette with your solution. So what does this look like when it's all together? So this is kind of what it's going to look like. It probably won't look exactly like this, but you have your burette, you have your pH sensor, and then you have your magnetic stir with a stir bar. What you're going to do is you're going to pipette acid into the beaker. You're going to pipette 10 mils of that acid into the beaker. And then you're going to add enough water to cover the pH sensor. So you're going to add your pH sensor in there, make sure it's not touching the bottom of the beaker, and then add enough water to cover it. They're going to place the beaker on the stir bar, and then you're going to remove the pH probe from your storage solution, rinse it off with DI water to get off the salts, and then attach it to the ring stand with a utility clamp and submerge it in your solution. Even though we've added water to this solution, it doesn't change our H+ ions. So we're just adding water for volume to increase, to cover our pH sensor. You're going to start the stir, making sure it doesn't hit the sensor, because remember, the probe is very sensitive. You also want to make sure that it's not stirring so fast and so much that it's splashing acid out of there. If you start splashing acid out of there, then you're going to have calculations which do not represent what was really the actual molarity of your solution. Rinse and fill the burette several times. So if I have not already done this, then what you'll need to do is add some of your base to the burette, just a little bit. Swirl your bait, take your burette and swirl it around a little bit to take that base and coat the sides of the burette. Dump it and do that several times. Attach your burette to the clamp and then start following your instructions. What you're going to do is you need to fill your base all the way up to the 0 line reading your meniscus. But remember, burettes read backwards. So this is actually 0, and then you're going to have 1, and then you're going to have 2, and so on. So the meniscus starts at 0 and it goes all the way down to 50. Next, you're going to start reading your lab and start data collection. So you are going to, here is our setup. All right, you have your stir bar in here, and then you have your acid and your probe in here. And what you're going to do is you're going to take the pH, and you're going to take that in increments, small increments. Probably you're going to start at 0 mLs of base added to it, and take that pH. Then you're going to put 0.0 or about 0.5 mils of base in there. Take the pH, keep that reading. And then you're going to go to the next one, and you're going to go at 1 mil. You're going to stop, keep that pH reading, and you're going to add that was at 1 mil. This is a cumulative volume. The more data points you make, the better. What you're going to do is you're going to get this nice little curve here, this pH graph. And this is a strong acid versus a strong base. And what we see at the middle of the sharp rise is pH 7. Okay, this is our equivalence point. This is where the moles of your OH ion is equal to the moles of your H plus ion. So as you're doing this, if you get 4 or 5 increments and your pH doesn't change anymore, such as in this area, then you can stop and you can start your calculations. But the more data points you have, then the better. When you get to the calculations, to find the molarity of the acid, you're going to find the milliliters of base at the equivalence point. Okay, that's going to be on your x-axis. Then you're going to find the moles of your base, and we know that we had 0.25 molarity of our NaOH. And then what you're going to do is your moles of your base is going to equal your moles of your acid. And we're going to do stoichiometry to figure out the molarity of our acid. So the acid moles divided by how much acid did we start out with? We started out with 10 milliliters. Even though you added water, we still had 10 milliliters. So that would be 0.01 liters. And that is going to give us our moles per liter, or our molarity of our acid. Okay, so you are going to come in Monday. Be prepared. It's going to be really crazy. I'll be stressed out trying to get this all done. You're going to need to be doing teamwork when one's setting up the probe, then and getting the acid ready, or one's getting the acid ready and the burette ready, then one needs to be getting the probe ready and working on that. So you need to be using teamwork and divide and conquer. If you have any questions, send me a text on Remind, and I will try to help you out. But first, ask your lab partner for help before you ask me. Have a good weekend.